Lilia，我看你说你没有时间写作业，然后你看有时间的时候把 Chapter 9的 challenge 做一下，至少是。Alright, uh, uh, okay, for Aaron, I'm studying for your not Chapter 9. For Chapter 9, Chapter 9 reviews are still some arithmetics. So those are very basic stuff. Um, yeah, so try some challenge problems. So I'm gonna cover three challenge problems before we go to Chapter 10. And for chapter 10, we almost finished last time. Last time we only have one last problem. And after that, we have also finished chapter 10. Okay, so today maybe we're just gonna do some questions in chapter 9 and 10 because I see that everyone is much behind our homework schedule. Okay, by this week you should finish chapter 10 review, but I only have so Rika only finished chapter 9 and Aaron only finished half of the chapter 9, right? So today we just do some questions in chapter 9 and also in chapter 10. Okay, so 9 to 22, a binary number consists of 17 digits, all of which are 1, and triple the number. So how many digits does it have, and also how many of them are 1s? So here basically it's just asking you to calculate 17 ones in base 2, and you're gonna time it by 3, right? And there were two ways to do it. Of course, one way is always to do a long multiplication, right? So for example, you could do this. You could say it's 1, so 17 ones, right? 1, 1, 1, 1, 1, 1. So 10 ones, 15, and 17 ones. So this is in binary. You want to triple the number, so meaning that you're going to time it by 3. But if you want to do a multiplication in a base number, you're going to convert this 3 into a base 2 number, right? So 3 in base 2 number is just 2 plus 1, so 1, 1, right? Okay, 1, 1 in base 2. So 1, 1, 0, 1, 1. Okay, so we do this. You just need to do a long multiplication. That's one way to do it. Okay. Now let's try to do this. It's 1 times 1. So that's 1. 1 times, so everything is 1, right? So basically here, I'm just gonna copy paste. So copy paste. Okay, you have first you have all the ones here, right? So times this one, you get all the ones here. And then you have all these ones times second digit. And of course you get the same ones. It's just that you're gonna align them by so leave this blank, right? This is actually 0. So this. Okay, Rika，你觉得这样 make sense 吗？你可以做个 long division，long multiplication。OK，丽丽，你觉得这样 make sense 吗？OK，
可是 triple the number 要乘三吗？
对，这个一不就是3吗？一 in
什么意思？
base two，这个一 in base two 啊，它不就是3吗？
哦，
对吧？In other words，就是
confuse 就
3。
是因为 triple 就是三嘛，我在想怎么会能乘三呢？它乘不了三。
哦，对，乘3，他说的是相当于就是说在一个 decimal 里面乘3，但是他说是 triple 嘛，就是3倍，就是问你说 in other words，就是说这个数啊，它加自己加3次得到什么结果吗？对不对？triple 是不是就是个数加自己加3遍啊？能理解吧？对，那加自己加3遍呢？在 decimal 里面它就是 times three，但是如果是在 binary 里面，binary 没有 three，你就把这个 three 换成 one one，那其实就这个数乘以 one one。所以你可以把这个数加3遍，也可以把这个数乘以 one one，或者呢，也可以把它换成 decimal，都可以啊，有很多种方法。OK，这样就 make sense 吧？我们待会再看个别的方法，OK？And we can also do in decimal systems. I'm gonna show you later. So now we're just gonna do addition. This is not hard, right? So just 1 plus 0, you have 1, and then 1 plus 1. 1 plus 1 in binary. This is binary, right? So 1 plus 1 is 1 0. So get a 0 here, carry over. 1, 0 plus 1, 1, carry over. 1, carry over, 1, carry over, 1, carry over, right? Just keep carrying over, carry over, carry over, carry over, carry over. Everything's the same. If you carry over, that's 1, 1. If you don't carry over, that's 1, 0. And in the end, you see here, it's 1 plus 1. In base 2 again, that's 1, 0. And that's it, right? Okay, does that make sense to you guys? Okay, Lily, Aaron, good. Lily, make sense? Okay, so then you can answer question A and B. I believe so. Initially, you had 17 digits. So now you have 2 more digits, so you have 19 digits, right? And 2 of them are zeros, so that means 17 of them are ones. Okay, this is one way to do it. We have another way to do it. Of course, you can just add it up 3 times. I'm gonna skip that. Another way to do this is to use the decimal system, okay? So this is, if you want to convert to decimal, is if you just do like 2 to the power of 0 plus 2 to the power of 1 to plus 2 squared plus 2 cubed plus 2 fourths, that's going to take a long time, right? But we can just add 1 to it. You guys remember we've done a similar thing before. I believe where? Here. This. Yeah. So we've done one thing here, a similar calculation here, right? This is 7 digits of 1 in binary. So we said that we could do 2 to the 6th plus 2 to the 5th plus 2 to the 4th, but this way you have to calculate for a long time, right? So instead of doing this, you can just add 1 to it so that it becomes, 8 digits, 1 followed by 7 zeros, and minus 1. In this case, you would know that it's 2 to the 7th minus 1. OK，Rika、Lily 看看有没有问题啊？Rika，你看这个没问题吧？如果是binary 里面有一堆一啊，你当然可以一个加，但是这样加比较费劲嘛，你要一直算，对不对？那你呢，干脆就把它变成，就给它加一个一，把它变成一堆零，然后再减一个一就可以了。这样子的话，有一堆零呢，你就直接是2的7次放在这里，就比较快嘛。OK， so similar methods include, for example, if you have a bunch of twos in a base 3 system, say you have 2, 2, 2, 2 in base 3, then you don't have to do 2 times, usually like normally we do 2 times 3 cubed plus 2 times 3 squared, etc., right? But you don't have to do this. It's just 1 away from a bunch of zeros, right? So if you add 1 to it, you just get 1, 0, 0, 0, 0 in base 3 and minus 1. And in this case, it just becomes 3 to the 4th minus 1. Okay? So in this question, we want to use this because we have a lot of digits. So here, we just change it to, well, 17 digits, so 1 followed by 17 zeros. 1, 0, 0, 0 in base 2. Here we have 17 copies of zeros, okay? So 1 followed by 17 zeros because you had 17 digits before, right? And then you minus 1. Yeah, so in this case, 17 zeros means that you have 2 to the 17th. Okay, not 18th, but 17th, right? Always remember for the first digit is 2 to the 0th. For the second digit is 2 to the 1th, 2 to the first power, 2 to the first power. And then 2 to the second for the third digit, 2 to the third, like 2 cubed for the fourth digit, etc., right? So for 18 digits, you only have 2 to the 17th. Okay, the power is only 17, then minus 1. Okay, and then you're going to triple this. So it time by 3, right? So you're going to time it by 3. Okay, now when you time by 3, if you just try to get a result and then convert it back to decimal, then should convert it back to binary, then it's gonna take again a long time, right? Okay, to convert it back to binary, and if you want to save time, the best strategy to do is that you can express your result in terms of powers of 2, right? So for example, if your answer is say 2 to the 18th, plus 2 to the 17th, plus 2 to the maybe 2 cubed, something like this, then you can easily write it as a binary number, because if you minus 1, you get a bunch of ones and stuff, right? So you want to express your result in powers of 2s. OK， 我看这有没有明白？瑞卡丽丽看有没有明白啊？就是说啊，这个地方我们先把这个数字呢变成2的17次方减1嘛，对吧？这样变完之后，如果你乘3，你就直接乘3的话，当然不是不行啊，你可以算出来这个结果，这个结果是不是一个 decimal number， 是一个10进制的数啊？然后你再把它换回成一个2进制的数，那是不是花很长的时间又很麻烦啊？对吧？但是如果你能把你的结果就像是这样表示成为就是一大堆2的几次方2的几次方的话，那在一个2进制里面是不是比较好换啊？比如说你的结果有一个2的17次方，那你就直接知道你的答案是这个嘛，对不对？对吧？记得我们那个进制转换吧，因为你是2进制嘛，所以一切的数字如果是2的几次方2的几次方，就可以直接写成2进制里面的数字了，对吧？1乘以2的17次方，所以第18个数是1嘛。OK， 如果是2的16次方呢，那就是第17个数是1，对不对？如果是2的3次方呢，这就是第四位数是1嘛，这样就直接写出来了 ，make sense？ 瑞克丽丽 make sense 吗？理解吗？对吧？所以我们希望我们的结果是2的几次方，这样我们会直接换回成2进制啊，就不需要再去把它具体结果算出来。像这里数还挺大的嘛，这个数把它算出来之后再换回成2进制，这样花很长时间。Okay, so here comes a key point. So the point is that we want to express our result, our product in power of 2s, right? In powers of 2s. So I'm going to change my 3 into 2 squared minus 1. Okay, so in this case, you have a bunch of 2 squared, right? Now you can have 2 to the 19th. So you do this, right? And then minus 2 to the 17th. And then minus 2 squared. And eventually add 1 to it. Okay, and now we can convert everything back to the binary system with ease, right? So the first one, 2 to the 19th. Again, 2 to the 17th means that you have 17 zeros after 1 in a binary system. So 2 to the 19th means that you have 19 zeros, right? So if 1 followed by 19 zeros. I'm just going to skip these, okay? Whatever. So here we have 19 zeros. 19 zeros. Okay, and then maybe I'm gonna write it down here. Okay, so the first number is 1 followed by 19 zeros in base 2. Okay, the second number, well, 2 to the 17th is just a number here, right? So 2 followed by 17 zeros. So 1 followed by 17 zeros in binary system. So 17 zeros. So you're gonna put your 1 here, right? This is 19. There are 19 zeros here. The 20th digit, the 19th digit, the 18th digit. Okay, and then now you have 17 zeros. So you're gonna align them nicely, like this. 0, 0, bunch of zeros, and now you have 17 zeros here. Okay. And then you have another subtraction and then plus 1. So let's wipe it out. We have another subtraction. So minus this and then minus 2 squared. So 2 squared, you have 2 zeros at the end, right? So minus 1, 0, 0 in base 2 and eventually plus 1 back. Okay, I'm going to still do this. I'm going to say here you have 17 zeros. OK，瑞克雷里看一下有没有问题啊？你看啊，这里关键一步呢，这里你看你会发现，首先第二种做法换成 decimal 是远没有第一种做法简单的。就第一种做法，你直接把3换成1，直接一乘完事儿了嘛，对吧？很简单的做法啊。所以呢，如果要是第一种做法没想到，或者无论如何，如果你要是觉得说要换成 decimal 的话，那 decimal 怎么做呢？顺便讲一下，那就是首先第一步呢，不要做就是2的16次方加2的15次方，一直这样做下来，一定要先给它加个1，然后再减掉一个1，就直接变成2的17次方减1，比较方便。方便完了之后呢，乘3的时候要把这个3换成2的平方减1，因为我们的目标是把最后的结果全部变成2的几次方。这样你2的几次方直接就写成二进制了嘛，对不对？因为二进就是2的几次方，3进就是3的几次方，4进就是4的几次方，对吧？所以呢，这个地方你不能直接乘3啊。如果你拿计算器敲或者怎么样，不管你自己怎么算，如果你假设我们拿计算器敲是多少了？我看看啊，17次方挺大的，2的11次方已经十几万了，减1的乘3，你直接拿计算器敲呢，实际这边会给到你393213，你再把这个数换成二进制，那就换死你了，对不对？换的很累很累，对吧？所以不要这么干。你要把这个3呢换成2，这样最后全部都是2的 power，OK？要把所有的2的 power 呢写回成 binary system， 然后呢你就可以做减法。OK，so let's make sense？还有没有疑问啊？有疑问问一下，没有疑问呢我们就继续。Okay, so if you don't have any question, let's first do the subtraction here. This is not hard because you have 17 zeros at the end, right? So basically, you just do 1, 0, 0 minus 1. So 1, 0, 0 minus 1 is just 1, 1, right? 1, 1 in base 2. 1, 1 plus 1 is 1, 0, 0. 1, 0, 0 minus 1 is 1, 1. So here, we can first do this part, just 17 zeros, and then 1, 1 here, right? Okay, so if that makes sense, we write down 1, 1, and then 17 zeros, 17 zeros, and then minus 1, 0, 0, and plus 1. Okay, and then we do 1 minus 1, 0, 0. So put let's write down one more 0 here, 1, 0, 0, minus. Okay, here again, you have 0 minus 0, 0 minus 0, so you have a 0 here, you have a 0 here. And then this is another 0. 0 minus 1 in binary, you have a 1 again, right? So 1, you're going to borrow 1, 1. You're going to borrow 1 from the previous digits, right? So you have a bunch of 1s. And then you have to borrow all these digits, right? You have to borrow all the digits from the zeros. You have 1s and 1s. And then you borrow 1 from here. So you get 1, 0. See if that makes sense? All of these zeros have to borrow a digit to this digit, right? Because 0 minus 1 is not enough. You have to borrow from the next digit, and that digit is also 0. So you have to borrow 1 again, and borrow 1 again, all the way down. So you have to borrow all the digits until you have this 1. And when you borrow 1 from 1, okay, it just becomes a 0. And you don't need to borrow anymore. So the first digit is also 1. Okay, and how many 1s do we have here? Here, you should have, line them up nicely. So remember that we have 17 zeros here, right? 17 zeros all together. You have 2 zeros at the end. So that means you have 15 zeros here. Right? So here you have 15 ones, sorry, not zeros, 15 ones. And then you have 2 zeros, so that in total you have 17 digits. And remember, you have 17 zeros in the beginning, right? So I think that should make sense. You borrow 1 from here, okay? And eventually you just add 1 back, right? Because you're going to do the 1 here yeah. So in the end, you have 1 0 and then 1 and 15 ones and then 1 0. So here you have 15 ones. So in total, we have 15 ones plus this one plus this one. You're gonna have 17 ones, right? And in total, you have 19 digits. Again, this answer is the same as we have done here. We have done using the long multiplication. So the long multiplication would be the easiest method to do, okay? Because if you do decimal, there were a lot of techniques you must employ. You're gonna first do this, you're gonna do convert your 3 into this, and then when you do subtraction, addition, you have to pay attention to all these digits. So it can be really hard. Okay, I'm gonna line them up here so that you can see that it is clearly 15 ones here, right? Because here you have 17 zeros, 17 digits. The last two zeros are still zeros, and these digits become ones. Okay, so 我们 Rita Lily 没问题吧？这里如果是要用十进制呢，就比较难做啊，要注意这些小技巧，因为你不注意小技巧的话，去 convert 那花太长时间了。然后在做这边的加减法的时候呢，一定要把这个，因为它这里数字比较多嘛，一定要把你有几个零几个一数清楚，就对齐就可以了啊，不用全把它列出来，只要是你就写有几个零几个一就写一下就行，然后把它们对齐，好吧？好吧呀。OK，Lily Aaron 看有没有疑问？没有疑问我们就继续往下啊。OK，看下一题。啊。924. Cleo needs to determine. Okay, let's read the question first. And yeah, Lily, Aaron, Ryan, I wanna maybe hear some ideas from you guys.瑞凯，你是道题不会做对吧？OK，
没有
那有可能
读懂。
我没有读懂题，那我给你解释一下啊。他说的意思呢，就是说有一个71777 digit base 12 的 integer 什么意思啊？就是说你现在有一个 base 12的 integer 没问题吧？12进制的整数，这个整数呢几位数呢？有7万多位数，有7万多位的一个整数啊，这个整数大不大呀？够大吧？你这个整数非常的大，7万多位，如果是十进制的话，那十进制里面每9位数是1个亿了，这都不知道多少个亿，你一都说不清楚了，明白吧？这是个超级无敌大的数，OK？而且它 base 12嘛，还会比 base 10还会更大一点，因为它12才进一位，对吧？然后呢，他说啊，他这个人呢想要看这么大的一个数是不是3的倍数。那么这个数呢，它虽然很大，但是它最后的5位数，看到吧？最后5位数啊，就刚好是71777，但它一共有7万多位数啊，所以其实很多很多数，它有好多好多数，最后结尾呢是以71777结尾，然后是 base 12，没问题吧？一共有7万多位数，你要想说写出来的话，第一面都写不下了。OK，那他就问说，怎么样能够非常快的、迅速的去看这一个数呢，是不是3的倍数？就问这个问题。你感觉现在这个题能读明白吗？明白是吧？如果明白，你看看应该怎么做？ Okay, Lily, Aaron, and Ryan 都想一下 all right? I'm gonna give you guys a hint. Try to express this in in decimal system. Okay, express this using the decimal system, using the base number. I think you can figure it out. What happens if you express this number using the base number? Okay, just anyone. Does anyone remember how to express this value in the decimal system using the base number? It's base 12, right? So digit times 12 to some power, digit time plus a digit times 12 to some power. Anyone?瑞肯记得吗？来，谁来做一下呀？Okay. What I meant here is that say that the first digit is A, because we don't actually know the first digit, right? If the first digit is A and you want to express its value in a decimal system, it becomes A times 12 to the power of, you have 71,777 digits, right? So it's going to be 12 to the power of 71,776 power. Remember? Okay. And let's say the next digit is B. And that's going to be B times 12 to the power of 71775, etc., right? You have 71,000 digits. So I'm gonna let's just skip all of them because we don't actually know their specific digits, right? What about this 7? Anyone? This 7 is 7 times 12 to the power of what? The first 7 here, the first
4.
digit here. 4. Good. 7 to the 4th, right? And then we have 1 times what? So everyone, could you continue to finish it?
1 to the power of 3. 7 times 12 to the power of 2. And then to the power of 12 to the power of 1, and then to the power of 0.
Very good. Very nice. Okay, it's not enough space. I'm just gonna, okay, just make it smaller. Okay, like this, 7 to the, like this, and then just plus 7. 7 times 12 to the zeros, which is just 7, right? Okay, does that make sense to everyone, right? Express the value in terms of the base number. Okay, Lily, make sense? Yeah, Rika, right? Now, how do we tell if this number is a multiple of 3 or not? What happens if you divide it by 3, guys?
Like the unit digit does not follow.
Exactly. Very good. Yes, yes, very good. Okay, so Ryan said that only the unit digit cannot be divided by 3, right? Because when you divide it by 3, you're dividing each term by 3, right? Dividing by 3 is the same as times 1/3. So you're gonna time each term by 1/3, each term by 1/3. But notice that 12 is a multiple of 3, right? So if you have a 12 in it, you can, this whole term can be divided by 3. So the first term, you have these many 12s there. It must be divisible by 3, right? So this digit can be divided by 3. This can be divided by 3. This can be divided by 3 because you have 3 12s. This can be divided by 3. This can be divided by 3, and only the last digit could not divide by 3. Okay. So only the last digit here. I'm gonna just circle it. So this means that this number is not a multiple of 3. Okay, so just gonna say here, 3 divides 12. Therefore, only the units digit matters. And then 3 does not divide by 7. So the number is not a multiple of 3. Not a multiple of 3. Okay. That's it. Okay, Rika, Lily, does that make sense? Rika make sense 吗？因为12能被3整除，对吧？凡是有12就被整除掉了。Okay, Aaron, does that make sense? Okay, so this, what does this remind us of? Does this remind us? Does this remind you of some divisibility rules you studied before? So, for example, what are even numbers? Even numbers are multiple of 2, right? So why does every number that ends with 0, 2, 4, 6, 8 can be divided by 2? It has the same reason, right? So let's look at some divisibility rules here, because they have the same reason as this question, okay? So divisibility rules. So for example, for 2, we know that you're just gonna end up with 0, 2, 4, 6, 8, right? Or in other words, even numbers. And that's because if you have any number in decimal system, any number, any digits, whatever, okay? But if you just end by, say let's end by 2, then when you express this digit, it can be, let's say the first digit is a times 10 to some power, I don't know, because it depends on how many digits you have, right? Say a times, let's say you have n plus 1 digits, okay? And then the second digit is just going to be 10 to the power n minus 1, blah, 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 okay? The 10th digit, let's say the 10th digit is m, okay? Then this m times 10 to the first power, right? And eventually just add the last digit. You will see that if you divide this number by 2, since 10 is a multiple of 2, right? Again, every term can be divided by 2 because they have a 10 in it. Doesn't really matter what number you times with, right? 1 times 10, 2 times 10, 3 times 10 doesn't really matter. They can all divide by 2. So the only thing you need to check is whether or not the last digit could be divided by 2. If the last digit can be divided by 2, then this whole number can be divided by 2, right? Okay, if the last digit cannot be divided by 2, then the whole number cannot be divided by 2, this whole number. So that's what we call them, that's why we call them even numbers, right? Even numbers can be divided by 2. You just need to check the last digit. Does that make sense? Okay, 瑞克，你看这个题 make sense 吧？其实一样的道理嘛，看出来吧 ？Okay, and that's also why for 5 you have the same divisibility rule, right? For 5, you also just need to check the last digit. If the last digit is 0 or 5, then the whole thing can be divided by 5. That has the same reason, because if you divide this whole number, say by 5 or 5, if you divide this whole number by 5, again, 10 is a multiple of 5, right? So when you divide it by 5, every term except for the last term, for the last digit, can be divided by 5. Make sense? So you only need to check the last digit. So last digit is 0, it can be divided by 5, it's just going to give you 0. If the last digit is 5, then it can be divided by 5, it gives you 1. All the other digits cannot be divided by 5. OK, 怎么样？瑞卡利看这个明白吧？所以对于2跟5呢，我们在实践之中嘛是有同样的 divisibility rule， 直接看末位数就可以了，对吧？2就看末位数，5也是看末位数，原因就是因为10是2和5的倍数，所以只要不是末位数，前面的数全部都要乘以10的几次方，那10全部能整除吗？那就只用看个位数可以了。OK, make sense? And then we can also look at review some other divisibility rules. So for example, if you guys remember, for 4, for 8, for powers of 2, right? For 4, we check last 2 digits. I think you guys remember, right? Last 2 digits. For 8, you're gonna check last 3 digits, and etc., right? Basically, 2 to the nth power, you're gonna check last n digits. And the reason for this is also the same as this. Okay, so for example, for 4, now 10 is not a multiple of 4, correct? 10 only has a 2 in it, but you have 100, right? 100 is a multiple of 4. So when you're dividing a number by 4, any digit after the hundredth digit, you don't need to check them. So let's say, for example, you have a number here, 78564. This number can be written as 7 times 10 to the 4th, 8 times 10 cubed, right? 5 times 100, and plus 64. I'll just write down here, okay? Again, when you divide this by 4, for example, okay? We know that 100 is a multiple of 4, right? So for this 100, we don't need to worry about it. It doesn't really matter what digit it times. Well, it's 100, so it can always be divided by 4, correct? Okay, and every digit after. So the only digits you need to worry about are the last 2 digits. So that's why for 4, you just need to take care of the last 2 digits. If the last 2 digits is a multiple of 4, then this whole number is a multiple of 4. And same for 8, right? If you are dividing by 8, you have to think, okay, only 1,000 is a multiple of 8. So you have to take care of the last 3 digits. Okay, does that matter? Does that make sense? So everyone, that makes sense to you? Okay, good. Rika Lily, make sense? 这边 Rika 有没有想明白和 Lily， 对吧？比如说你除以4，因为100是4的倍，10是那个100是4的倍数嘛，所以100以上的什么100啊、几百、几千、几万都不用管了，对吧？因为它们都是4的倍数，因为100在，一除就除尽了，对吧？不管它们是几种除得尽，你只用看最后2位数是不是4的倍数。所以对于4来说，你就看最后2位数。那对于8来说呢，1000是8的倍数，对吧？你又得乘个2嘛，乘一个2就乘一个5，对吧？因为是十进制，你1000是8的倍数，所以所有的数只要在1000以上，比如说这个7和8，它一定是8的倍数，因为8000嘛，或者7000或者6000，不管你几千都是8的倍数，因为有1000在。而底下这3位数呢，那你不知道，你就得看看这3位数是不是8的倍数。这就为什么对于2的 power 呢，我们有这么一个 divisibility rule， 跟这道题是一样的啊。那这个其实也是后面章节的内容啊，我就顺便也讲 ，OK， 就这道题，好吧？好 ，OK， 有没有疑问 ，Rika Lily？ 看看，我看 Ryan 都明白了啊。OK， 如果没问题的话呢，我们再看啊。And more divisibility rules, right? Do you guys remember anything else that has the same divisibility rule as 4 and 8? You also need to check the last 2 digits, check last 3 digits.
10.
10, yeah, or 5, right? 5. So for 5, we check the last digit. But for 5 squared, for 25, we also check the last 2 digits. Remember, for 125, we check the last 3 digits. And to be specific, for 5 to the nth power, we check the last n digits. And again, that's the same reason. It has the same reason as powers of 2, right? Because you can, if you divide it by 4 or if you divide it by 25, again, 100 is a multiple of them both, right? Of both. So you don't need to worry about 100. You just need to look at the last 2 digits. If you divide by 8 or 125, it has the same reason, right? So both are factors of 1,000. So you don't need to worry about any digits after 1,000th digit, okay? You just need to take care of the last 3 digits. So if the last 3 digits are multiples of 8 or multiples of 125, then this whole number will be a multiple of 8 or 125. OK， 瑞可丽丽的吗？记得吗？这个是不是我们很小就学过？应该对吧？你4啊、8这些2的 power 都是这些规律吗？12就25、125之5的 power 呢，也是这些规律。 原因在这里了，原因就是10是2乘5，100是4乘25，1000呢，那就是8乘125，就是2的3次方乘5的3次方。所以我们只用数到它能整除的那一位就可以了。后面那些呢，那我就没办法了，因为那个10不够除嘛，那你就只能看一下它能不能除得尽，能除得尽，那整个数就除得尽，对吧？Okay, Aaron, that makes sense. Okay, good. Let's look at one more divisibility rule. You guys find this makes sense. So for 9, we all know that for 3 and 9, we can look at a digit sum, right? Find the digit sum. Okay, so why does this work? And why does it not work for any other number, right? So let's first look at 9 and think it can make sense. So I'm gonna just use this example again. Let's see if this number is a multiple of 9. So I'm gonna wipe this out. 6 times 10, and 4 times 1. Okay, whatever. Now, if you divide this number by 9, what would happen? First of all, since 10 is not a multiple of 9, so none of the 10s can be divided by 9, right? Okay, but what about the remainders of these powers of 10 divided by 9? So let's look at remainders. So for example, 10 divided by 9, or you can start with 10 to the 0th. 10 to the 0 divided by 9, of course, remainder is 1, right? 10 divided by 9, remainder is also 1. 10 squared divided by 9, because you have 99, remainder is also 1, right? And 10 cubed, 1,000 divided by 9, again, you can get 999, so the remainder is always 1, you see? So for any number, for any power of 10, if you divide it by 9, the remainder is always 1, right? Okay, so now if you divide all of these by 9, then the remainder of each term, okay, I'm gonna write it down, put it here. Okay, now we look at the remainder. So remember, remainder, we can use this from chapter 10, right? Chapter 10, we said that this is the remainder, or this represents the units digit, right? Units digit or remainder, that they mean the same, right? Okay, so we divide by this. 10 to the 4th divided by 9, the remainder is 1. So that means if you have 7 times 10 to the 4th, then the remainder would just be 7, right? Because 1 times 10 to the 4th divided by 9, remainder is 1, right? If you time it by 2, of course, the remainder is 2. You time by 3, the remainder is 3, etc., right? So the remainder is 7. For this one, the remainder is 8. For this, remainder is 5. For 6 times 10, remainder is 6. For 4, remainder is 4. And this is just the sum of the digits. And if the sum of digits or the sum of the remainders can be divided by 9, then this whole thing can be divided by 9, right? So we can add them up. So this is what? 15, 20, 30. And 30 cannot be divided by 9, so this whole number cannot be divided by 9. Okay, see if that makes sense. This might be hard to understand, but if I give you an analogy, maybe you can understand it better. Okay, I'm pretty sure you can understand, because when I use the analogy to explain to, say, even grade 3 students, they can understand. Okay, so the analogy is that consider this number to be, say, the number of candies. Okay, now you have 78,564 candies. Okay, when you divide it by 4, I'm dividing this many candies to 9 people, correct? Now, how do I divide it? I can first divide this many candies into some piles. I can divide them into 10 to the 4th, which is 10,000 candies a pile, and 7 piles, right? Let me write it down. So now you have 78564 candies. So I'm going to divide it into some piles. So first we have a pile, okay, of 10,000 candies, right? A pile of 10,000 candies. And we have 7 of these pile, right? 7 piles of this. We have a pile of 1,000 candies. We have 8 piles. We have 100 candies as a pile, and we have 5 piles. So you see, this is exactly the digit sum, right? We have 6 piles of 10 candies. And then lastly, we have just 4 individual candies, right? So I'm gonna just draw a candy here. No, candy. How do I draw a candy? Okay, candy, right? You have 4 individual candies, okay? I'm gonna divide all of them into 9 people, okay? To 9 people. Now let's think what happens if you divide them. If you divide this pile, remember, if you divide 10,000 by 9, remainder is 1, right? So that means each person gets 1,101 and 11 candies, and there's a 1 candy left. Remainder is 1, right? So divide this by 9, remainder is 1. Does that make sense to everyone? 你是不是把一万个糖分给9个人，你剩1个糖啊？对吧？那我是不是把这7万个糖分成了7堆1万个糖啊？对吧？ 7 piles of 10,000 candies. Each pile you have remainder of 1. 7 piles, it gives you remainder of 7. Make sense? In other words, if you divide 70,000 candies to 9 people, then everyone gets how much? I don't know, but how many? I don't know. But I just know that I'm gonna have 7 candies remaining. They cannot be divisible, right? All the other candies, we just hand them out. Make sense? Okay, and similar to every other piles. So again, this 1,000 divided by 9, remainder is 1. You have 8 piles, so you have remainder of 8. 100, remainder of 1. You have 5 piles, you have 5 as a remainder. 10 divided by 9, remainder is 1, times 6, so you have remainder of 6. And 4 candies, then remainder, of course, is 4. Okay, so at this moment, we have divided basically most of the candies. We only have some candies remaining, right? So of course, I'm gonna add up all the remaining candies. I'm gonna collect all of them and then divide them to 9 people again. So that's why we're gonna find the digit sum, right? We find the digit sum or the sum of the remainders, 7 plus 8 plus 5 plus 6 plus 4, which is 30 here. So I'm gonna collect all the remaining candies. We have 30 candies. And if this can be divided by 9, then of course everything can be divided by 9. And if this cannot be divided by 9, then everything cannot be divided by 9, right? So that's why the digit sum tells you whether or not a number can be divided by 9. Okay, see if that makes sense? So Aaron, does that make sense to you? Okay, good. Okay, this is actually, I remember chapter 11, maybe the next chapter or the next 2 chapters, I don't remember. But anyway, we're gonna talk about them. So yeah, I'm just gonna cover a little bit here. 怎么样 ，Rika、Lily 看不明白，对吧？整个过程啊，这么多糖果，对吧？我永远可以分成这些 piles， 这些分 piles 的方法是不是就是我们的 digit sum 嘛？这个 digit bundles 对不对？对吧？这 digit bundles 吧？当你除以9的时候，是不是1万个糖分给9个人，你剩1个糖啊？那7堆1万个糖，你就剩7个糖嘛，对吧？道理是一样的，1000颗糖分给9个人，你剩1个糖；你有8堆，你就剩8个糖；100个糖分给9个人，剩1个糖；你有5堆，就剩5个糖，等等等等。所以呢，最后呢，我们把这些所有剩的糖全部加起来，这剩的糖果的数量就是每一这些堆糖除以9的余数，对吧？这个余数呢，刚好就是数字本身，其实因为每一个这个10的几次方除以9都余1，所以刚好是数字本身，所以数字和其实就是余数和。余数和呢，如果能除进9，那因为其他已经除完9，我已经分完了嘛，就剩这些糖了，所以剩的这些糖如果能被9整除，刚好分给9个人，那整个这个数能分给9个人了，对吧？就除以9了，就除尽了。如果呢数除不尽，那就除不尽。这就为什么对于这个9来说呢，我们找的是 digit sum， 因为不管你是10的几次方除以9都余1，就是有这么一个性质导致的啊。看有没有疑问 ，Rika Lily？ 好 ，good， OK。If there's no question, then for 3 we have the same reason. Okay, again, it's because for any power of 10, if you divide it by 3, the remainder is still 1, right? Because divided by 9, divided by 3 doesn't really have any difference here. Rika, 你怎么回事？这么冷吗？ Okay, OK 明白吗？瑞克雷里，对吧？因为我除以9，任何的10的几次方除以9是余1，那我除以3是不是也余1啊？对吧？所以就是我们3跟9呢，它的这个 divisibility rule 是一样的，都是找这个 digit sum. So for 3, I can just change it here, right? So 3 or 9, 3 or 9 doesn't really matter. Okay, any power of 10 divided by 3. So here we can also just divide it by 3. The remainder is also 1. So same applies here. If you divide all these candies to 3 people, again, every pile will have a remainder of 1. You just add them up. So here you will see that for the remaining number of candies, you have 30, right? And 30 can be divided by 3. So that means this whole number can be divided by 3. Because you can actually divide the remaining number of candies to 3 people, but not to 9 people, but only to 3 people. OK， 瑞卡克明白对吧？除以3是一样的意思吧，对不对？因为每一堆这个糖你分给3个人，它的 remainder 跟9是一样的嘛，对吧？直接把它们全加起来，就看看能不能除3除几就可以了。OK， 丽丽都明白吧？好吧。Okay, and yeah, we can actually use this to explain the divisibility rule for 11 as well. Okay, remember 11, the rule for 11 is to find the alternate digit sum. And that's again because 1 divided by 11 remainder is 1. 10 divided by 11, you actually need one more candy. You need one more candy. And 100 divided by 11 is 1. 1,000 divided by 11, you need one more candy. It's like +1, -1 stuff, -1 stuff. Okay, but yeah, we'll explain this later. So because I believe for powers of 2, powers of 5, and 3 and 9, these are the easiest to understand for now. Okay, maybe later we can once we get to understand the reason and also like the reasoning behind all the divisibility rules, you can actually invent divisibility rules by yourself. Okay, I once wrote a paper with another student of mine, and like he's doing university, he's writing a math paper. I was helping him, and yeah, we wrote we came up with some divisibility rules, like of 37, of 13, of some bigger numbers on ourselves. Okay, yeah, so you can invent some rules by yourselves, but yeah, that will be later. Any questions so far for the divisibility rules for this question? Okay, so again, if you understand this, you can invent divisibility rules even for other base numbers, right? Even for other base numbers. Okay, so for example, in base 12, you can also find a digit sum to determine if it is a multiple of 11. Okay, why? Because if you have base 12, then everything have like times 12, right? And then if you divide by 11, then, well, 12 divided by 11, the remainder is 1. Everything you have a remainder of 1 and stuff, okay? But anyway, doesn't matter. In your exam, you won't see this. In exams, you only need to use divisibility rules for decimal systems, okay, for decimal numbers. And sometimes it may ask you to determine if a number is a multiple of something in other base numbers. Then you just need to do a long division, right? You just do a long division. Okay, let's do one last question in chapter 9, and then we're gonna go to chapter 10. So after we do this, we take a break and we do chapter 10 questions, okay? So here, we're gonna find, give you guys some time to read it. We're gonna find all the integers that are 3-digit palindromes in base 5, and then add all of them up. Okay. So this question brings us back to the sum of palindromes that we learned before. Okay, if you guys remember from chapter 7, I believe, we learned how to find the sum of palindromes, like in base 10, right? This is to find the sum of palindromes in base 5. Okay, so let's review the method we learned.
老师，palindrome 是什么来着？
palindrome 不记得，叫回文啊，就是正的念、反的念的数字是一样的。比如说101，比如说404，比如说252啊，比如说383，这是单是3位数的 palindromes 啊，你也可以更多嘛，对吧？之前我们在第7章就有学过 palindromes，你不记得了，对吧？第7章学过这个 palindromes 的和，当时学的是4位数 palindromes 的和 ，OK？ 那比如说4位数可以是1551，如果是5位数呢，可以是35135153嘛。我们当时不是还学过，就是有几个 palindromes 啊，你都不记得了吗？对吧？有几个 palindromes 怎么去数啊？这样子。OK， 好。So to find the sum of palindromes, that we learned that we're gonna first find the average, and then multiply the average with the total number of palindromes. That we can find a sum. Okay, because we know that sum divided by the number of numbers is the average, right? So we first find the average and we time the number of numbers, and then we can find the sum. Okay, so here I don't want to do an example with palindromes in base 10 again. Let's just do it in base 5, and then you can remember. I think you will recall the method that we found the sum of the palindromes. Okay, so what palindromes do we have in base 5? In base 5, the only digits we have are 0 to 4, right? So basically, you're just gonna find all the palindromes with 0 and 4 in it, 3-digit palindromes, right? So we have, let's list from the smallest, 101, 111, all the way to 141, right? 202, 212, all the way till 242, 303, 404. That's it, right? And all the way to 444. Here, 343. That makes sense, right? And all of these are in base 5. And these are all the 3-digit palindromes in base 5. We're gonna find the sum of all of them and also express your answer in base 5. So that means we're just gonna find the sum of all of them in base 5. So we don't have to convert all of them back to decimal system, right? Okay, and of course, if you need to convert all of them into that decimal system, that takes too long. Even if you want to find your answer in base 10, we're going to first find the answer in base 5 and then convert them into base 10. Rather than converting every number into base 10 and add them up, it takes too much time, right? Okay? 好，看明白瑞克丽丽，对吧？这些是不是所有 base 5里面的3位数的 palindromes 啊？一下就列出来了嘛，很容易列出来，没问题吧？列这个很容易啊。列完了之后呢，它让我们把它们的和找到，并且要是 base 5的结果，所以我们就直接把它们全加起来就可以了，就不需要把它全换成 decimal 了啊。因为换成 decimal 换成实进值非常麻烦 ，OK 吧？而且即使是题目让你找到，让你把最后的结果写成一个 decimal 呢，那也是我们先把它全部加起来 in base 5，最后再换成 decimal， 而不是每个都换成 decimal。那这样子你不是做猴年马月做不完吗？对吧 ？OK， and how do we find a sum? We first find the average, remember, and then we find a number of numbers. So to find the average for palindromes, if you recall, it's actually just basically just the smallest plus the largest, and then the second smallest plus the second largest. You always have the same sum. So for example, here, 101 plus 444 in base 5. This gives you 1 plus 4, 0, right? Because it's base 5, okay? 1 plus 4, 0, you carry over 1. 0 plus 4 plus 1, right? 0 plus 4 plus this one. Again, you have a 0, and you carry over 1. Okay, maybe you carry over 1 here. And then eventually 1 plus 4, again, 1 0 plus this one, so 1 1. Make sense? 101 plus 444 is 1100. An easier way to do this is that you can add this one. Okay, here you have a 1 in 101, right? Oh my God. Okay, anyway. So you can add this one to 444 so that you get 1000. And then add this one, so get 1100. Make sense? Okay, this is equivalent to, if you're using decimal system, this is similar to, for example, if you're doing 101 plus 99. In a decimal system, 1 plus 9, you're going to carry over. The same, right? See? So if you're doing this addition, of course, you do 1 plus 99 is 1000 plus 100 is 1100. So when you're doing base 5 arithmetic, that's the same, okay? 444 plus 1, that's 1000 plus 100, you get 1100. OK， 没问题吧？瑞看看丽丽没问题吧？这个算法啊，这里当然你可以直接加啊，但是如果你对这个 base number 够熟悉的话，你就会发现这个东西啊，它跟我们这个 base 10的这个999加1是一个道理啊。因为444在5进制里面相当于999在10进制嘛，差1就全部变0了，对不对？所以直接把这个一给，就是1000，再加个100嘛，对不对？直接变1100了，好吧？ Okay, if that makes sense. Then we can carry on. So the second smallest is 111. The second largest is 434. You will see that it gives you the same answer because it's literally just 10 subtracted from 444 and added to 101, right? The first number is 101 plus 10. The 434 number is 444 minus 10, right? So they cancel out, you get the same number, 1100 in base 5. Remember, this is also the pattern we found when we try to find the sum of palindromes in decimal system. Okay, in a decimal system, you have the same pattern, right? 大家记得吧，在10进制里面也是一样的嘛。你比如说101加999，下一个数呢是111加989，一样的吗？一个多10，一个少10，对不对？你的 sum 永远是一样的 ，OK？ So every pair has the same sum, right? And by the way, if you divide it by 2, you just get the average. Okay, so here we just need to find how many pairs of this sum do we have. So every 2 numbers is a pair, right? So that means you just need to know how many numbers do we have here. So how many numbers do we have here? 4 columns. How many rows? 0, look at the middle digit, 5, right? So 5 rows, 4 columns, 20 numbers. Yes, very good. So 4 times 5, 20 numbers, right? 20 numbers. So since you have 20 numbers, every 2 numbers is a pair. That means you have 2 pairs, right? So there are many more pairs, but just 20 divided by 2, you have 10 pairs. Okay, does it make sense? Yeah, and that's it. Okay, so 10 pairs, so just time by 10. So eventually we have 1100 in base 5 times 10, okay? But we want our answer in base 5, correct? So but this 10 is the decimal system. Remember, you are doing 4 times 5, everything is decimal, okay? So this 10 is actually in the decimal system. You have to convert it into a base 5 system. So it's going to be 1100 in base 5 times 10 in base 10 is, well, 20 in base 5. Because 20 is just 2 times 5, right? 10 is 2 times 5, so 20 in base 5. So it's going to be times 20 in base 5. And even if in base 5, we put all the trailing zeros at the end, 2 times 1, 1 is just 2, 2, right? Make sense? 1, 1 times 2 is 2, 2. You have 3 zeros at the end in base 5. Okay, so this is the answer. This is the sum okay, of all the 3-digit palindromes in base 5, and also the sum is also in base 5, okay? Okay, so please remember the method because in some math competition question in past exams, some questions have asked about the sum of palindromes in base 10 also and also in the other bases. Okay, so get familiar with the relative method. 我把这个方法呢，我们再重复一遍，非常简单啊。不管是任何 base 的 palindromes，首先呢，你先把它们列出来，对吧？列出来很简单吧？最小的列几个，最大的列几个，中间稍微一列就列完了。列完了之后呢，所有的 palindrome 都有一个规律，就是最大的加最小的，第二大的加第二小的等等，它们的和都是一样的。因为是 palindrome 嘛 ，palindrome 你最大的这些数，你只用就是把这个中间这个数减小一点，这个数加大一点，它们就刚好对称了嘛，对不对？你就直接相加就行了啊。所以每一组的和都是一样的。然后你就要看看你有几组呢？那就先把整个数字求出来，对吧？这刚好是5行4列，有20个数字，20个数字除以2就有10组，有十对儿，对不对？每一对儿是一样的和啊，所以最后就拿这个和乘以这个对数就可以了。如果十进制就直接乘，如果是其他进制呢，就再把这个10变成其他进制就好了。一定要变一下，因为你不能拿10进制的数去乘5进制的数，得出来的那就不知道是啥了，因为也不是10进，也不是5进制，不行了嘛，对吧？不同进制数之间不能直接乘，一定要换一下，换成同一个进制的。OK， 所以呢，就把这个10进制的呢换成5进制的数，然后再一乘就可以了。好，看有没有疑问，没疑问我们就休息一下 ，OK？我们 have a break，然后我们做 chapter 10的题。
Share my screen.
Oh, yeah, share your screen? Sure. Go ahead.
Wait. Okay.
There's a green button. Yeah.
Okay, this thing. I don't get it.
Okay. I
It's
haven't.
like a thing, but I don't really know what it.
Oh, you already. Okay, that's law of cosines. Yeah.
Like, I
mhm,
calculated, like, I got to this point. Oh, shit. Okay. Like this part.
mhm.
But then I didn't get the same answer, and I don't know what I did wrong. Okay.
Really? Okay. So you're gonna use a
so
calculator, right?
yeah. So it's 12. Yeah. So it's the answer is like 144 plus 324 minus like
There's a squared here.
432, which is 36.
Okay.
So
Yeah,
36.
there's a squared here, Lily. Did you take a square root?
Yeah, but okay. So 36 cos thing 65 degrees,
Cosine.
right? Right. So don't you just do 36 times in 65 and then you just punch it in the calculator with a cosine?
In your
And then
are you using
unsquare
a
it?
scientific calculator or are you using just your iPhone?
Okay, well,
Oh, this calculator. Okay, yeah. Okay, let's try. Let's see what
right.
happens.
So 36 times 65 and then that, right? Which is
No. Oh, okay. Here you're gonna first calculate cosine 65 degrees. First
it's the
calculate
same.
cosine, yeah, and then times 12, 18 times 2 times 36, okay, times 12, yeah, and times 12.
Wait, why would you times 12?
Here 2 times 18 times 12, right? 2 times 18 is 36, 36 times 12,
Oh,
and
wait,
then
I
times
just like minused it out.
okay, yeah, you have to calculate, you have to find a product of all of these. 2 times 18, 36, 36 times 12, and then times cosine 65 degrees, which is about 0.4 something, right?
Oh, okay, I get it. Never mind. I did it
Okay.
wrong.
Yeah,
Okay, that's
you can try again and see if you get this result. Yeah.
okay.
Okay. Law of cosines, that's math 11.
It is horrible.
Horrible? It's okay if you
Wait,
just
no,
apply
it's
this.
not math 11, it's math 10, I think.
Well, maybe for your school, but for standard curriculum, it's math 11. Yeah. It's math 11. But yeah, later on when we get to advanced geometry, we actually get to prove law of cosines, because in your school you well normally
I don't
they
understand how it works. It
Yeah.
only works on the calculator.
It works in a calculator. It only works because for cosine, unless you have special values like 45 degrees, 30 degrees, 60 degrees, you have to use a calculator, right? But law of cosines has been tested in many math contests. Like for example, last year in Euclid is grade 12, right? I remember question 8 used law of cosines when you try to solve a triangle, something like that. Okay, law of cosine is very important. So in our class later, we will learn how to prove it, both by geometry and by algebra. Okay, we will learn both ways to prove law of cosines. Yeah, and we can learn how to prove it like in 2 different ways in geometry, which is really fun. Yeah, and Euclid. Let me show you last year Euclid. Oh, and also for Aaron, I was trying to talk to you. If you want to take Katie, go to this website, and you know this website, right? And download some maybe past 5 years of Katie and try to do them. Okay, as practice.
Is it really hard? Is grade 10 hard? Because I don't have a spot for grade 9.
I know, but grade 10 I think is fine. Even grade 11 I think is fine. Only grade 12 for Canadian math competitions is can be pretty hard. Grade 11 is not that hard. Grade 10 is.
Yeah, like, do I have
What's
the
that?
ability to do it? Like, do you think I have the ability to do a grade 10 contest?
Yeah, I think you do, because if you understand our algebra class, just grade 10 Katie is most about linear equations, linear functions, linear inequalities, that kind of stuff. So you can do some past exams and have a look. Okay. And also Lily, you see, this is 2022, so last year Euclid grade 12 math competition, right? You see 7B. 7B is the law of cosines. This question. You know that BC is 2, CD is 1, AC to AD is 3 to 4. You know a cosine, and you're gonna find the length here. Okay, and you're gonna actually need to apply law of cosines in this question. Just apply it in the question in triangle ABC, and apply it again in question in triangle ACD. Anyway, for Katie, okay.哦，瑞卡，你有没有报学校的这个考试啊？今年你应该。
今年没报，明年打算报。
哦，你今年没报呢？今年可以考个 Grade 9，考个 Pascal 啊，考个 Katie 之类的，对吧？
他学校又不给证明，考了没什么用。
是没什么太大用，对上大学确实没什么大用。就是考了，就是说，因为数学的学习是个连续的，你不可能说是一直不考，咔就考12，你考不会了嘛？要每年都考一考。对，反正他也无所谓，考。对，反正考个好不好的无所谓，确实是就是考一下，就是有经历有感受一下，对吧？For Katie or Pascal, so Aaron, yeah, download some past exams and get to know the format. Okay, you have 3 parts, I think you should know, and part A and B should be pretty easy for you if you're aiming for a high score. Okay, so when you do the past exams, make sure you can easily do part A and part B. So the first 20 questions. If you have trouble doing first 20 questions, let me know and see how I can help you. Okay, because first 20 questions should be pretty like basic. Okay, very elementary. And the first question in part C is usually easy as well. Okay, so if you are aiming for a high score, pay attention to the last 4 questions. I believe only last 4 questions can be hard. Okay, yeah. For part C, you don't have multiple choice. You have to write down an answer. So there's no multiple choice here. But for part A and B, you have A, B, C, D to choose from. Okay. Anyway, that's enough about that. And then let's continue our chapter 10. So where were I? Where's I? Okay, we were here last time, so let's wrap up the last example problem and let's do some more practices. So here, wait, I actually have it, last lesson here, I think. No, which was the lesson? Lesson 13, yeah. Okay, here. Okay, I'm gonna paste it. Okay, so let's first review what we have done last time. Okay, last time. The question is really just the last one. Okay, how many of the positive divisors of 6 to the power of 2006 have a unit digit of 6? Okay, you see the power is 2006. So this was from well, an exam. What exam? Like an exam in the States, like math counts or something in 2006. Okay, so you see, for 6 to the power of 2006, there were many divisors, right? There were a lot of divisors, maybe millions of them. We're gonna see which divisor has a unit digit of 6, right? Okay. So we know that 6 to the power of 2006 is, if you prime factorize it, it's gonna be 2 to the power of 2006 times 3 to the power of 2006, right? By the way, the total number of divisors, if you guys remember, you just need to add 1 to the power, right? And then add up and then multiply them, right? So if you want to find the total number of divisors, which is the function d, divisor function, the number of divisors for this power of 6, for 6 to the power of 2006, is going to be 2007 squared, right? So that's about 4 million. Make sense? Okay. So how many of them have a unit digit of 6? To study this, we have to go. We basically have to to look at like question A and B and stuff. Okay, because for any divisor of for any factor of this number, it must be 2 to the some power times 3 to the some power. Correct? Right? Because 2 and 3 are the only prime factors of this number of 6 to the power of 2006. 好，Rick 丽丽看这个步没问题吧？你它题目呢是6的2的6次方里面有多少个因数，对吧？它因数有很多个，对不对？有400万个。他说这些因数里面有多少个因数，它的个位数是6。OK， 那么我首先去想，那它的因数是不是一定长成2的几次方乘以3的几次方的形式啊？我是不是要把2的几次方乘以3的几次方的形式的能给到我个位数为6的所有情况要列出来啊，对吧？才能去找到它一共有几个数。OK， so that's what question A, B, C, D are doing. So let's say question A. Let's see question A. So question A says, if you have just 2 to the power of 1, then when you time by 3, what numbers give you a unit digit of 6? Okay, so you will see that we have listed it down here. Basically, just every time you need to time by 3, right? 2 times 3 is 6, 6 times 3 is 8, 8 times 3 is 4, 4 times 3 is 2, and you start to cycle. So what this tells us is that if you have 2 to the power of 1, in order to have a unit digit of 6, you see you have to get 3 to the first power, or the next one is 2 times 3 to the power of 6, right? This one, 2 times 3, you get 6 again. So in order to have a unit digit of 6, yeah, the power of 3 must be either 1 or 6, or since it cycles in in 4, the next time you get a unit digit of 6 should be like 5 later, right? 5 powers later. So that would be the next one you should get 3 to the 7th, right? 3 to the 7th is here, 3 to the 8th is here, 3 to the 9th is here, and then 3 to the 10th. Right? So 1 to 2 to 3 to, okay, sorry, I wrote it wrong. This is actually 4. Okay, that was weird. Yeah, this makes more sense. Yeah, it should be like the difference here should be 4. So 1, 2, 3, 4, and then 5. Okay, this makes much more sense, right? So for 3 to the first power, the unit series is 6. 3 squared, unit series is 8. 3 cubed, that's 4. 3 to the 4th, that's 2, right? And then you go back to 3 to the 5th, that's 6 again. Okay? And then you keep doing this, since it cycles in 4, you just find every other 4 numbers, right? Say the next is 3 to the power of 6 is going to be here, right? 3 to the power of 7, 3 to the power of 8, and then 3 to the 9th. See if that makes sense to you guys? So the power of 3 here must be 1 more than a multiple of 4, right? 0 plus 1 or 4 plus 1 or 8 plus 1. So 1 more than a multiple of 4 in order for you to have a unit digit of 6. So that's 3 to the power of, let's say, 4k plus 1. Okay, that's a multiple of 4k, and then plus 1, okay? 1 more than a multiple of 4. 好，先看这里明不明白啊？看看 Rick 和 Lily 有没有搞明白？看 Aaron 好像是明白了，对吧？你看 Rick 和 Lily 有没有明白啊？我们这道题呢，他问说它有多少个 factors，多少个 divisor， 它的个位数是6，对吧？我们刚刚也说了，它必须要有2和3组成它的 divisor， 对不对？要是多少个2乘以多少个3，所以我们要看2乘3的情况下，看一下规律，几个2乘以几个3会给到你这个 unit digit 是6呢？对不对？我们先假设我们看一个2，假设2是一个啊，那有几个3呢？你看是不是有3的1次方，这是一个3啊，对吧？然后3的5次方也可以给到你6，对不对？然后3的9次方也给到你6，这里是 cycle 的这个形式嘛，6842、6842，或者说2684、2684，你可以很清楚的看到这边这个规律，对吧？其实这个框没有打的不好啊，最好是这样看一组，对吧？直接从头开始看一组。
所以它是过几个就会重复是吗？
对，看出来就重复了吗？
对，
我们上节课对，我们上节课是不是说这种就是乘法里面看 unit digit 一定会重复啊，对吧？上节课我们看了好多 example 在上面啊，都重复了。这节课，上节课我们看了好多 example 都重复了，对不对？会重复，对吧？这里你可以看2乘1是2嘛，对吧？乘一个3个位数是6，乘一个3个位数是8，因为3、6、18，再乘一个3，3、8、24，所以个位数是4，对不对？然后再乘一个3呢，3、4、12回到2了。那既然你回到2，是不是之后又是2684、2684，一直做2684啊？对吧？然后这个6是不是相当于在每一组的2684里面是第2个？第一个就刚好是每一组里面的第一个，那也就是说除以4是没有余数的嘛，对不对？没有 remainder 的。你这里相当于除4余1啊，那3的1次方嘛。然后下一个呢，到了这个6的就是5，除以4也余1。到了下一个3的9次方，是不是除4也余1啊？对吧？这个6、7、8、9，因为是有同样的这么一个规律嘛 ，OK？ 看有没有疑问？所以这里意思就是说，如果你的2是1次方的话，那对于你的3来说呢，必须得是就是4的倍数加1这么多次方，才能给到你个位数是6。我看看这里有没有问题啊？好，那如果没问题的话呢，我们就继续看下一个 ，OK？ So let's look at this. What about you have like 2 squared, right? So 2 squared, last time we just did this, but we're gonna list it up. So first, we do 3 to the power of 0, right? So here is just 4. So 2 squared times 3 to the power of 1. What is the unit digit here? Anyone? Does anyone remember how to find a unit digit? This is 4, right? You time by another 3. What is the unit digit?
2.
2. Yeah. So 3 times 4, 12. So that's 2. And then?
6.
And then?
8.
Good. And then?
4.
Yeah. For 2. Good. So it starts to cycle, right? Let's do one more. So we have another 6 here. And that's a 6. So we see a nice pattern here. Okay. Make sense? So now you will see that if we have 2 squared, then the power of 3, in order for us to have a unit digit of 6, has to be here, which is squared, or here, which is to the power of 6, right? The difference between the powers here, 2 to 6, is 4 again. And then that should make sense because it cycles in 4. It cycles in a group of 4. That makes sense, right? So 2 or 6, that means they are multiples of 4 plus 2. In other words, when they divided by 4, the remainder is 2. Okay, so that means we have 4k plus 2 if you want. You don't have to write down like this, just in your mind. You know that the powers of 3 in this case have to be multiples of 4 plus 2, or divided by 4, remainder is 2, right? What happens in your mind, right? Remember, if you're in an exam, you don't actually have to write this down, right? You just on your draft paper, you just put your thought there. Okay, I'm just writing this down to show our work, but in an exam you don't have to write present your work this clearly, because most exams are just about the answer. You don't have to show your work, right? Okay, see if that makes sense. If that makes sense, we can look at next power. So far we haven't found any relationship between the power of 2 and the power of 3, so we have to further investigate until we find something out, right? So, and then we're gonna do, let's say, 2 cubed, right? So we have done 2 to the first power, 2 squared, 2 to the third power. We actually also need to do like 2 to the zeroth, but yeah, we actually need to do 2 to the zeroth, right? Because 2 to the zeroth, only 3 to some power can also be divisors of 6 to the power of 2006. Okay, so what about this? So let's say 3, and then first one is 1. 1 times 3 is 3. 3 times 3 is 9. 3 times 9, 7. And then 7 times 3, 1, right? Okay, so you will see that if you don't have any 2s, there's no 6 here. And that should make sense, right? Because if you don't have any 2, that's not even an even number. You don't have 2s in it, right? So no even number, of course you don't have 6. 6, if you end with 6, that's an even number, right? So no 6 in this case. Does that make sense? Okay, so that's why in this question in A, B, C, D, they actually have ignored this case, because that's not an even number. Okay, so and then we can do 2 cubed times 3. So 2 cubed. Okay, so this one gives us 8, right? 8 times 3 is 4. 4 times 3 is 2. 2 times 3 is 6. We have a 6 here. Okay, and 3 times 6, 6 times 3 is going to be 8 again. So again, it cycles in 4. It always cycles in 4, you see? So it cycles in 4. Again, to have a unit digit of 6, the power is 3. And since it cycles in 4, so what is the what does the power of 3 have to be in order, in this case, in order for the unit digit to be 6. Anyone? If it is 2 cubed, 瑞克利想一下，如果这里是2的3次方，就跟前面一样，2的1次方的时候呢，你3的 power 必须要除4于1才能给到你个位数是6，对吧？当你的 power 是2的 power 是2的时候，你的 unit digit 对不对？你3的 power 必须得是除4于2才能给到你这个6，对吧？OK， 才能给到你 unit digit 等于6，对不对？那如果说2的 power 是3呢？这个规律是什么规律啊？你们看一下跟上面的规律比一下，这是3的平方，对吧？2的1次方的时候是3的1次方呢，这里是3的3次方才能给到你6，所以它得是这个3的 power 得是多少才能给到你6啊？大家想一下，把这个地方搞明白。因为这个题呢比较复杂，要分 case 或一直去想啊，所以如果我一直在讲，你要是不想的话呢，就相当于白学了。其实你一定要自己动动脑，看看这地方我们跟上在讲啥。啊，没有吗？没有什么想法吗？各位，这应该不难吧？如果你要是想不出来，肯定是没有明白这边在干啥啊。我觉得如果明白这边干啥，不可能想不出来，好吧？OK，所以再看看 A1，你的一个 case 一个 case 想，不是说 A1 B1 的问题，这里跟 A1 B 没有关系啊，就是我们直接做真正的这道题，这道题就是这道题，好吧？就是6的206次方里面有多少个 divisor， 它的个位数是6，对不对？那么我再带你们走一遍啊，6的 divisor 是不是一定是由2的 a 次方乘以3的 b 次方组成啊？对吧？所以就是要看这个 a 跟 b 各自要是几的情况下，你的这个 divisor 呢，不是你的 divisor，你这个就是你这个 divisor 它的 unit digit 也是6，没问题吧？那你就要看，那你就要分情况讨论，对不对？因为你光是这样想也想不出来，你必须得讨论，得去试才能试出来，对吧？一定要试啊！所以先假设是2的0次方，2的0次方呢一定没有6嘛，对不对？因为2的0次方压根就没有2，你这个数呢压根就不是偶数，怎么可能用6结尾呢？对吧？6结尾是个偶数嘛，对不对？所以没有2的0次方是没有任何 case 的，对吧？然后如果是2的1次方呢？如果你有一个2，我们通过研究了几个规律发现啊，它是2648、2684、2684四个一组循环。这样子的话，我们就知道，比如说2乘以3的1次方个位数是6，2乘以3的5次方个位数也是6，2乘以3的9次方个位数是6，等等等等，对不对？所以如果是2的1次方的话，你这个3的 power 必须得是1啊、5啊、9啊。那1、5、9什么规律？就是除4于1嘛，对不对？OK 吧？包括这个你们都学过嘛？这是找规律，四个一组，四个一组，在第二个的这个数就是除4于1嘛。你就想四个一组嘛，1、2、3、4，对不对？1、2、3、4，你就是除这个，反正这不是因为你是这边其实从0开始嘛，所以至于就是说你第一个数是除4，没有余数，那0、4，第二个数是1、5、9，对吧？1、5、9的话除4于1，第三个数呢2、6、10除4于2嘛，第四个数这边是3，然后是7，对吧？所以除4于3嘛，OK。之所以你选择除4，是因为你四个一组，所以你要除4，对不对？同样道理啊，你看，如果是2的平方呢？2的平方就是我们也是就直接算就行了，对不对？发现它是4268这个规律，4268的话，这里是2的平方乘以3的平方有6，2的平方乘以3的6次方也是6，这也很明显是26，对吧？以后每次加4就是了，2、6、10、14、18、22，这些都可以给到你个位数为6。这些的规律是不是除4于2啊？那这一规律是什么？2的3次方的规律是什么？你看还是一样，8、4、2、6的循环，对吧？第一个为3，你说下一个数得为几啊？下一个还要得到6，是2的3次方乘以3的几次方呢
？6
？6吗？ Okay, Aaron, 我们来列一下 all right? So 3 to the 5th is 4, right? 3 to the 6th, 8, 4, and then 2, right? And then 3 to the 7, 2 times 3, 6. You see?
Oh, it's a jump of 4 each time.
Yeah, jump of 4. You see, every time you jump of 4. So 3 to the 1st, 3 to the 5th, 3 to the 2nd, 3 to the 6th, right? You see? In other examples, is the every time increase by 4. So that's why we divided by 4, right? Divided by 4, remainder is 2. Yeah, so Aaron, this notation might not be familiar to you. That's why I was reluctant to use this notation. But if I don't use a notation, I don't know how to show the work, right? So yeah, but the idea here is that once you found the first power that makes you have a digit of 6, then the next power you just need to add 6. Sorry, add 4. Add 4 to it because it cycles in 4. It cycles in 4, right? So that means every 4 power later, you have the same digit number, units digit. It cycles in 4, right? So you see, for example, if you want a 4, 3, 12, 0, the next time you see 4 is 3 to the 4th, 0 to 4, right? And 1 to 5, 2 to 6, every time you add 4 to it. Okay, good, Aaron. Okay, makes sense? So here you could say, yeah, the next is 3 to the 7th. Okay, I think you got maybe a little bit hang of it. Ricky 看看这里有没有明白啊？这道题啊，我觉得如果你们不自己去专门课后去做的话，光听我讲一遍，肯定是理解不了的。这道题你们一定要自己去做。其实讲了很多题，难的题，我之前讲了很多题，有些过程很长的那种 case work 啊，你们一定要自己去试，因为考试的难题全是这样。OK，Ryan 就知道，因为 Ryan 是跟我学比较高年级的这个竞赛，他只是对 Number Theory 不是很熟，我们来讲一下而已。Ryan 就知道，你高年级的题目，基本上11年级、12年级的竞赛，尤其是12年级赛，像 AMC 12啊，包括 Amy 啊，那些难的题，真的是一道题做上1个小时、2个小时都不为过，因为 case 实在太多太多了，一定要自己去想，看你能不能把这个 case work 做清楚，好吧？所以大家就是一定要自己去试一下，你就会发现这个每次都加4。OK， 难的题基本就是这样，你要找这个规律。OK， 这个呢也是加4。我想你看看有没有理解？4个是什么？还没加4加4可以了，对吧？丽丽看有没有问题啊？
如果不是4个一组的话，比如说是5个一组是加5吗？
对，你5个一组循环，你肯定加5嘛，因为5个一组循环嘛，它不停的循环。你比如说举个例子，假设我们说02468循环，这是5个一组，然后再02468，假设是这样。那你比如说假设这是第1个数、第2个数、第3个数、第4个数、第5个数，对吧？那你是不是第6个数、第7个数？你看到没有？1到6是加5，2到7加5嘛，3就到8也加5嘛，对吧？5个循环就加5，8个循环加8，对不对？但是你这个规律呢，你是不用背的，就是说你一试就试出来了，一定要自己尝试一下就知道了。OK， yeah. Anyway, so 3 and 7, right? 只是如果要把这么3、7啊什么的表示出来的话，那3、7或者再加4、11，3、7、11这些都啥规律啊？那我只能说除4余3嘛，对吧？所以我在表示的时候只能说4k 加3这种写法，因为你看4k 加3，k 等于0不就是3吗？k 等于1就是7吗？k 等于2呢就是11。4k 加3就是说4的倍数加3，那就是除以4余3的意思，对吧？当然这个 notation 呢是比较正式的 notation 呢，就是说你自己考试呢，你总发现个规律就可以了，你就知道哦，就是除4余3，或者你写3、7、11都可以。我写4k 加3只是为了要 show work， 写的稍微正规一点，好吧？其实我也不愿意写这个，我自己考试的时候我写过程，那谁会写这种东西？哪会写这么详细？我在脑子里面呢，直接一个 case word 一个 case word 过，我就知道在不同的 case word 是什么情况就完事儿了，根本不用写这么详细，写这么正规出来嘛，对吧？OK， 你看我们现在找到挺多规律了。OK，so if you have 1, 2, only 1, 2, a single 2, then you need 4k plus 1 threes. If you have 2 twos, you need 4k plus 2 threes. Okay, if you have 3 twos, you have 4k plus 3 threes. Okay, so it seems like in the next scenario, when we have 2 to the power 4, okay. Actually, I'm just gonna wipe this out, okay? Because 2 to the power 0 doesn't give you 6, right? It's not an even number. It's simple. I'm gonna wipe it out so that I can put this case over here. And what about the next case? The next case. If you make a prediction based on the pattern we have seen so far, you should see it, right? You have 1, 2, you need 4k plus 1 3s, right? You have 2 2s, you need 4k plus 2 3s. If you have 3 2s, you need 4k plus 3 3s. Okay, so if you have 4 2s, then based on this pattern we have seen so far, you should have 4k plus 4 3s, right? And the 4k plus 4 is just a multiple of 4, so you can just write down 4k. You have 4k 3s, correct? And let's confirm it. So 2 to the 4th, we know that's 16. So the unit city is 6. You see, it is 6. You don't need any 3. And then if you time by 1, 3, 6 times 3 is 8. Another 3 gives you 4. One more 3 gives you 2. And then another 3 gives you 6 again. You see, it cycles in 4 again. And then to get the unit digit to be 6, you just need 0th power or the 4th power or the 8th power, right? So just 4kth power, multiples of 4. OK， 看有没有明白，对吧 ？So 这就是它的规律，看到没有？我们规律说一遍啊。你一个2的时候呢，你这个3的这个 power 也得是 4k 加1，就是说除以4要于1。2个2的时候就除以4要于2。3个2的时候除以4要于3，4个2的时候除以4，刚好整数了。那比如说5个2呢，那是不是回到第一个组了？所以你是不是有5个2，你就跟第一组是一样的呀？你又转回来了嘛？6个2呢，又跟第二组一样；7个2呢，又跟第三组一样；而8个2呢，跟第四组一样。而具体来说就是什么规律啊？你看2是不是什么1 5啊？2如果是1 5的话，那下一个就得是2的9次方，是不是这些2里面也是2的 4k 加1次方？因为你159也是除4于1嘛，看到没有？而下面也是一样，2的2次方、2的6次方，下一个是2的10次方，是不是也是除4于2啊？所以其实它第一个 case 就是说2跟3的 power 都得是除4于1。第二个 case 呢，就是2跟3的 power 啊，它们都得是除4于2才可以。第三个 case 呢，3跟7都除4于3吗？所以第三个 case 就是说2跟3都得是除4于3，以及最后这个 case 呢，它们俩都得是除4整除。也就是2跟3的 power 得是一样大的，这个也 make sense 啊，因为2跟3的 power 一样大的话，2、3得6嘛，是不是 unit digit 是 6 啊？而且6怎么乘6都是6嘛，6 6 36，6 6 36，一直乘的还是6啊，依旧是6。OK， 所以你看我们就有4种 case 了，而4种 case 呢，你就各自数出来它们有几个divisor 就可以了。OK， 所以你看我们最后来数这个 divisor。divisor 呢？ So the number of divisors depends on the number of choices you have for powers of 2s and 3s, right? So we need to determine the number of the number of choices. So for let's say A and B, you have many choices. So first, if the number of choices for A is let's say 4k plus 1, right? The first case is 4k plus 1. Then the number of choices for A, to be specific, you have. I'm gonna maybe make it bigger, like this. 好，瑞克马上过完，我就讲一个 case， 剩下的给你们自己去做啊，这样子快，这样你们就先去。你对于 A 来说，你有谁可以选啊？你是不是可以选1？我们刚刚说了，可以选5，对吧？可以选9，对吧？是不是刚刚这个就是对到我们第一个 case 啊，对吧？你看2可以选1、5、9，然后一直加4，一直加4嘛。对于3来说也是一样，可以选1、5、9，对吧？4可以加1、5、9，一直这样算下去，是不是对于 A 来说可以是1、5、9再加4、13，一直选到什么时候呢？那最多是2006个，对吧？2006个是不是可以选到？因为这也是4的倍数加1，是不是可以选到2004加1就选到2005啊？ 对于 B 来说是一样 ，B 也是能选1、5、9等等等等，一直到2005，所有的这些 case 都可以给到你个位数为6，对吧？那在这类 case 上一共有几个呢？那你就看到它的 number of choices， 对不对 ？number of choice 这是几个数？1到2005嘛。那第一个呢是0加1，4乘以0加1。第二个数是4乘以1加1，第三个数是4乘以2加1，对吧？一直到2005呢是4乘以2004，就是501加1。所以从0加1到501加1是不是一共502个数啊？这里一共是502个数，502个 choices for A。And also here 这是不是一样呢？也是502个 choices 啊。所以 in the
Is this
first
like arithmetic sequence where you find the number of numbers and find choices?
exactly, yeah, arithmetic sequence, yes, yeah. Okay, so we have this many choices for A, this many choices for B. So in this case, we have 502 squared, this many divisors. Okay, so 25 and 2 and 1004. So this many divisors. This is only for the first case. 大家明白？后面的 case 都给大家自己去做，因为瑞克得下课了。就是说，对于这个情况，我们刚刚看到第一个情况就是，只要2的 power 是什么呀？2的 power 是4k 加1的形式，就是说是除4于1，也就是1、5、9、13等等等等这些数，以及 b 的 power 呢也刚好是这些数任意一个数，它的 unit digit 就会是6。比如说你随便举一个，比如说2的5次方、3的9次方，随便一搭配啊，2的5次方、3的9次方。或者你说2的2005次方，3的，比如说来个2001次方，随便配2005次方，3的比如3的9次方都可以。这每一个数它的 unit digit 都是6，这是我们刚刚发现的规律嘛，对吧 ？OK， 这是第一个规律，就能给到我们这么多个 divisors， 然后就一直这样算就可以了。第二个也算出来，第三个 case 也算出来，第四个 case 算出来，4个 case 全部算完之后呢，全部加起来就是最后的答案了。好吧，所以这个过程一定要自己去试一下，然后把这个过程试明白，看看怎么做的啊。那我们下节课在一块的把这个题做完，然后做点别的。